Hi, welcome to the video solutions for physics. This is Edexcel IAL Physics Unit 1, June 2014, Part 2. So let's start. Question number 12. A skateboarder throws a ball vertically upward while traveling a constant horizontal speed. A skateboarder catches the ball moment later whilst still moving horizontally. Explain why the ball can be caught even though it was thrown vertically upward and the skateboarder is moving horizontally. Ignore the effect of air resistance. So effect of air resistance is ignored and a skateboarder is moving horizontally with the constant speed. Meaning at the time when the ball is thrown upward, the ball also has a horizontal velocity, and this horizontal velocity of the ball is as same as that of the skateboarder. So the horizontal motion and the vertical motions are independent. They don't affect one another. So horizontally air resistance is ignored and horizontal velocity remains same. So horizontal distance covered by the ball and the skateboarder is same. While vertically as weight is acting, so first the velocity is decreased and then increased due to a net force acting on the ball. And these points you need to write in your answer. Question 13. Two identical magnet X and Y are suspended by a light thread from a point P. Like poles are placed next to one another and repel as shown below. Okay, so these are like pole, magnet X and magnet Y. The free body diagram of magnet X is shown below. Okay, so this is magnet X and tension, repulsive force and weight. Show that T is about 0.2 Newton. Mass of the bar magnet is 0.015. This is a question regarding a vector and the resultant and the component. So what do? We try to find the component of the vector, and if you see this angle is 20 degree and you can resolve this T, which is this, into its component. So this is T and this angle is 20 degree. For this right triangle, this is opposite component, which is T sine 20, and the vertical component in upward direction, this is T cos 20. And if you need to find the T, because the mass is given, so you can compare vertical forces. That means T cos 20 acting vertically upward equal to the weight, which is mg. And if you put value of the mass 0.015 times 9.8, so T is equal to 0.015 times 9.81 and then divided by cos of 20. So you can find T as 0.16 Newton. This is the value of T. B. Calculate the magnitude of R. R is the repulsive force, and if you see the vector diagram, repulsive force R is acting leftward and the component of horizontal component of T, which is T sine 20, is acting rightward, and that means R is equal to T sine 20, and you have already found t as 0.16, you can put the value of t and then sine 20, and then you say that r is equal to 0.055 Newton. This is the value of r. C. State the magnitude of repulsive force that magnet X exerts on magnet Y and justify your answer. Clearly, if you see repulsive force R from magnet Y is applying force on magnet X in that direction, meaning magnet X apply force on magnet Y in that direction. And according to Newton's third law, both forces must be same. So force of magnet X on magnet Y, so F of X on Y is also 0.055 Newton due to Newton's third law. A moving walkway transports people horizontally over a short distance. A child stands on a walkway that is moving at a constant speed of 1.9 meters per second. Halfway along the walkway, the child turns around and attempts to walk backward. The start of the walkway at the steady speed of 1.9 meters per second. Explain why the child will not reach the start of the walkway. If you see, if walkway is going in that direction with the speed of 1.9 meters second minus 1 and halfway between, the child starts walking in that direction. So the speed, you can say that minus 1.9 meter per second. So meaning, with reference to the ground, the resultant velocity of the boy is 0. If resultant velocity is 0, then displacement covered by the boy is also 0. It is because boy is moving in opposite direction with the same speed. That's why it cannot reach to the end of the walkway. (14b) Two floors in a building are connected by a stationary ramp at an angle of 15 degrees to the horizontal and also by a staircase at an angle of 45 degrees to the horizontal. A child walks up the ramp at a steady speed of 1.9 meters per second, taking 25 seconds to reach the next floor. Show that the work done by the child is about 5 kilojoules. The mass of the child is 45 kg. So a child is walking up the ramp. This question is all about inclined plane. Inclined plane. Meaning you have horizontal ground and a plane making some angle with the ground, and in this case this ramp is making 15 degrees, and then the boy is walking up. So if you recall the situation of the inclined plane, so for an inclined plane you have object and the weight act downward and the contact force is upward, and for the component of W we have W cos theta, and then we have W sin theta. And this W sin theta is the parallel component. So the important point in this case is, if someone or something is moving along the plane, either going up or down, the force acting on the object is not W, but the component of the W, which is W sin theta. So if the child is walking up the ramp, it is doing work against the W sin theta component. W sin theta. So you can find the work done, which is W is equal to force into distance, and the force is the component of the weight acting parallel to the inclined plane, which is W sin theta, into displacement, and the child is walking with the steady speed, that means constant speed of 1.9, and it takes 25 meters to walk up. So you can for distance you can use S is equal to VT. Here I'm using a symbol S, and you can replace S with the D. So D is VT, so V into T. And finally, W is mg sin theta into V into T. You plugging all the values. Mass is 45, G is 9.81, theta is 15, V is 1.6, and T is 25. Plugging all the value, you multiply it, then you can have a work done is equal to around 5429.25. This is the work done joule, or you can round it off till 5429 or maybe 5430 joule. It's fine. This is the work done. And on another occasion, the child uses the staircase to reach the next floor in 12 seconds. Calculate the power developed by the child as she uses the staircase. Calculate the power. Power is energy upon time. And in this case, energy is energy used or energy output by the child, or you can say a work done. So no matter what, you use a ramp or a staircase, height covered by the child would be same. That means if you use the staircase, the work done will be same as you go along the ramp. So you can say that the work done is as same as you found in the previous part, and time is 12 seconds. So you can say that P is equal to 5429 divided by 12 seconds. If you do that, power is around 452 watt. In an investigation of how acceleration varies with the force, a student used the apparatus shown in the diagram below. These are the light gates and trolley. Okay, the pulling mass. Two light gates were positioned at a distance s apart with the first gate at the start position of the trolley. The student released the 1 kg trolley, which was accelerated by hanging masses. The trolley started a timer as it passed through the first light gate, and stopped the timer as it passed through the second light gate. The student recorded the time T for the timer. The procedure was repeated several times. Each time the student removed a mass M from a hanging masses and added it to the trolley, reducing the acceleration force. Okay. A results table with the following columns was then completed. Total hanging masses m kg, time t second, accelerating force, and acceleration. State how the student obtained the value for the accelerating force. So accelerating force is due to hanging mass. So hanging mass, that means if you do hanging mass multiply by 9.81, that means you can find W, which is equal to force F. Explain how a student should calculate the value of acceleration A of the trolley using T. Clearly, if you recall the diagram, you have a light gate number 1 and the light gate number 2, and we know the distance traveled between the two light gates. And at the start of the light gate, we can assume that the velocity of the trolley is 0. So we can use S equal ut plus half at square. And u is 0. So S is half at square and A is equal to 2S by t square. This is how you can figure out acceleration. Transferring mass m from the hanging masses and adding to a trolley means that the total mass being accelerated each time remains constant. State why the total mass being accelerated should remain constant. Because a student is investigating relation between acceleration and the force, and the most common equation or the relation between these two quantities is F is equal to ma, and in this case you can say that m should be constant, so that we can say that F proportional to A or A is proportional to F. That's why m is constant. A graph is plotted for accelerating force against acceleration. Sketch the graph you would expect the student to obtain. Because we have a direct relation, so we can expect a graph of force acceleration is a straight line. And part 2 state what quantity is represented by a gradient of the graph. So if you find the gradient, clearly gradient is equal to force upon acceleration, because vertical height will be value of force and the horizontal length, or we can say the run, is acceleration. So F upon A, and if you see F equal to ma, and if you send A on the other side, it becomes F upon A, which is equal to the mass. So gradient will give you mass. The time t could have been measured using a stopwatch. Suggest two disadvantages of using a stopwatch rather than a light gauge and the timer to measure t. Of course, if you don't use the light gauge and you use a stopwatch, the main disadvantage is it will involve a human error or a reaction time into it, and there might be some systematic error or a zero error in the stopwatch. And if we are using analog stopwatch, so there will be a parallax error. And of course, because we are measuring distance, so in a measuring distance we might have a parallax error. But for a stopwatch, the human reaction time and the zero error is also involved. That's it for this part. Thank you very much. Have a nice time.